volume today. Talk about going through fast. Then we have average value, arc length, and then we're going to get into polars and finish up right before break. Then when we come back from break, we'll do chapter 7. There's 6 sections in 7. Some new material, very important material, differential equations. So we're going to draw this problem. And so first I'm going to draw. We're going to rotate around x equals -1. So I'm going to put this in the middle of my board. And I want x equal to -1. There it is. But I'm going to change the color. Okay. The problem that I saw that some of you had was, how do you graph this problem here? You could say y is equal to 0, and when y is equal to 0, what's x going to be? 2. Does anybody recognize what this shape is? It's a circle, because if you square both sides, you get x squared equals 4 minus y squared. If you add y squared to both sides, and the radius ends up being 2. Okay, so I'm going to draw that. Now, it's not the top half of the circle. If it were the top half of the circle, it would be y equals the square root of 4 minus x squared. It's x equals, so that means it's sideways. So it's the right-hand side of the circle. Let's see. It's that. And then I'm going to clone it. Nope, it's not a function, but I can still do the problem. You're right. And when they're not functions, that's right. Aren't they lined up? I'm a little tilted too. I didn't move it though. Okay. I'm going to color it. Any particular color? One problem is it's then hard to see my drawings on there, but that's okay. I'll make it work. And I have a model for you. Okay. This is going to rotate around an axis. And you can decide all you want, but this is an apple. Isn't it an apple? What if you then slice it? You don't want to slice it vertically because then you get those weird shapes. But what if you slice it horizontally? Trying to get this to be nice. You should get a circle if I could get it to work. But if you think about it, you core an apple. That's what's happened here. You core the apple, and then you slice it. You get apple rings, don't you? Apple rings. No, that's an inverse. It's an inverse. But it's not defined that way. So x is equal to the square root of this. Is x going to be ever negative? No. Plot points. Now on my Inspire, I could actually maybe graph that. Well, yes, but what? Okay, here's the question. It's a good question. When you square both sides, okay, guys? Ari? Yes. Well, we'll get there. We're not there yet. But the question is, guys, when you square both sides, this equation here, x squared equals 4 minus y squared, is not the same as this equation. They have the same possible solutions, but there's no guarantee. So when you do x equals some function of y, that's going to be something on its side like this. If you plot points in here, you let y be equal to 4, then what's x equal to? Sorry, y equals 2, excuse me. Then x is equal to 0. That's this point, and you can do negative 2. So if you plot points, you'll see that. Shh, guys. Okay, the next question that has arisen was how am I going to find the radius? No, it is not the same equation. You've been maybe told wrong. If I do this, I'm going to erase this, but I'm going to say, x plus 2 is equal to 4. When you subtract 2 from both sides, you get a new equation. You get a new equation, and the numbers that make this one true, which would be 2, obviously, might make that one true. So, no, it isn't. What if I have the square root of x is equal to negative 3? Let's square both sides. Some of you are pretty smart. You probably realize what the answer is going to be. But x is equal to 9. Does that make that equation true? No. But this makes 9 makes this equation true. When you transform them, you get an equation that has the same candidates for solutions, but not necessarily will they always work. That's why you get extraneous solutions. It is not the same equation. But the numbers that make this one true might make that true. Did anybody sit and say, why did you square that? Because I know automatically there's no number I can put in there to make that true. Well, real number. Okay, so I'm going to get this out of the way because it's in my way. But that is a great question to ask. Should have been asked a long time ago, but but maybe it takes a little maturity to get there. Okay, let's do this. Now, what are these going to be? These are apple rings, which are washers. Let me draw a washer. I'm trying to figure out what color I can do. Oh, that's not going to work. Let's try red. That's not very good either, is it? Okay, let's go back to black. Now you got to be careful. Getting the radius is all geometry. Okay, you see the washer there? Okay, and the radius, the little radius is right there. What's the little radius equal to? 1. No matter what you do, the little radius is always 1. That was a constant. Now we got to get the big radius. Here's where you have to think and use geometry. This is always 1 because of the drawing. It's not always going to be that way, but it says x equals negative 1. When we do our rotation, we start from the axis of rotation and go to the actual function, not its image, not the rotated one, but the original one. Well, no matter what I do to get over here, I have 1. But how do you find this length? That's the x-coordinate. So what's the big radius? X plus 1. No calculus have we even used yet. This is geometry. So that's the reason why I gave you the AP exams, for you to practice with those. Okay, so what's the formula? What's the volume for one slice? Okay, guys, it's pi. It's the big radius squared minus pi little radius squared. You're taking the volume of the outside minus the volume of that cylinder, that core you took out, and it's delta y or delta x. We didn't decide. Yes. Big R is the length from here to this curve. This is the x coordinate. Hey, guys. Because this distance, this was x equal negative 1. This distance is a 1 unit. Always, isn't it? From here to here. That's that core. that you threw out. Or in my case, get to the horses. Yeah, I haven't finished it. Times, Eric, times what? What's the thickness here? Delta y. You see that this distance right here is the change in the y values. Honestly, that's delta x, that's delta y. But delta y is the little piece. Okay? So now we're going to integrate this. Here's the calculus. Let's factor out a pi. And it's r squared minus little r squared dy. Is that the same as capital R minus little r quantity squared? No. Okay, guess what mistakes are made on the exam? Right there. Now, if you mess up with the integrand or the limits of integration, possibly you're only eligible for 1 point out of the 3. I really don't know. You could have. We didn't have to use calculus. But what our apple really isn't a sphere. We have a weird function. But actually it's not because it's rotated around 1. I don't think it's going to work because it's rotated around 1. If it was rotated around the y-axis, then yes, where there's no hole in the middle. The hole in the middle has changed it. Actually, you probably can. Do the sphere minus the hole in the middle. I don't know. Try it. Guys, if you're talking, please don't. I can't hear. Matt? What about big R? Big R is the distance from here, which is always 1, plus the distance from that axis over here. That's the x coordinate. Okay, let's put that in. Volume equals, Nick, pi. The big radius is x plus 1 squared minus the little radius, which is 1 squared, and it's dy. So now what do you have to do? Which variable do you want in your problem? Yes, but which variable do I want? Y. So if you don't do, I don't see how you can do it without the differential. Okay, Trevor? You can't do it without the differential because the differential tells you the variable you want. So what's the y? What do I want? I want y's there, so I want x. Sorry. It shouldn't be there, but anyway. Okay, x is the square root of 4 minus y squared, right? I'm sure it's okay, though. That's a very dangerous place. Okay, guys, what was the x? Square root of 4 minus y squared plus 1 quantity squared. This is the x coordinate. Remember, x was equal to the square root of 4 minus y squared. We are. It just says I have to be in terms of y. So I have to solve for x in terms of y. But they gave it to me. What is x in terms of y? It's right here, square root of 4 minus y squared. I have to use this function. It could be a different function. Just what it is. That's why you want to do the AP problem. Okay? And then it's minus 1 squared, and it's dy. Oh, what do I need? What do I need now? I'm not done. I need the limits of integration. I'll try not to hit that. Okay, so if you look at your picture, where do the y's start? And y equals where? That's right, at negative 2. The y's start here, go all the way up to y equals, I look at the picture. This is all geometry. Marissa, do you know how to do this? Kind of. Okay, guys, do you have it written down? And where are we integrating from? Is there an easier way? Isn't the top half of that apple the same as the bottom half of that apple? Couldn't we just do 2 pi, and it's 0 to 2? Well, see, on a multiple choice question, they might have done the doubling of it as your answer. Who knows? Because I took from minus 2 to 2 and cut it in half. 0 to 2. The top half of the apple and the bottom half of the apple are the same, so I just doubled it. I want from negative 2 to 2 is equal to 2 times the integral from 0 to 2. You can. It's just easier to substitute in a 0. Numerically, it's easier. But it doesn't matter. They're both. Now, the only thing is on the exam, it's multiple choice. It's possible that they aren't going to give you the negative 2 to 2 answer. They'll give you the doubling one. They love to do that to you. That's how they make it harder. Okay. Are we ready for the last one? Now, one of the other questions I've had, Trevor, Nick, Eric, is how would you put this on your calculator? Because that's a y. I would type it in with x's because they're dummy variables. So I'd make that an x, and I'd make that an x, and I'd be done. If you want me to integrate it, I will. But the lesson here is how to set it up. I think you, I mean, maybe I'm wrong, but I think you know how to integrate those on your calculator. I'm making a video. Yep. Okay, Eric, are we ready to go to the last kind of problem? Okay. I love these because they're easy. It says, let the base of a solid be the first quadrant plane region bounded by that parabola, the x-axis, the y-axis, and the cross-sections perpendicular to the x-axis are squares. Well, you know what I did? I decided you needed a visual model, so I looked up the Tower of Hanoi. Ever play that game? And there it is. Okay? These are all different cross sections. And if you were to pull one out, it would be a square. And how would you find the volume of your square cross section? The side squared times how thick it is, right? So that's what it's asking. Do you see how you get a solid out of square cross sections? Are you going to get a pi in your answer? Zach, are you going to get a pi in your answer? Nope. No pi. You guys forgot to bring the pi. So don't forget to bring the pi next time. But you see, the solid is created in a different manner. Are you seeing that? The cross sections will look like that. So now I'm going to do my best to draw this, but I really don't care because I just want the cross section. I'm going to do a two-dimensional figure and a three-dimensional figure. One of these is wrong. Now, have you seen the new three-dimensional pen that's out there on Kickstarter? Kickstarter, there's a three-dimensional pen. Now, this would be very cool to be able to draw this for you. Nice. Okay. Guys, what does this look like? Okay, this is our last problem, so let's just get it done. If x is equal to 2, what's the y value? If x equals 2, y equals 0. Because I really want to know where this is 0. Okay, guys. When x is 0, what's y? 1. Okay. So there's our parabola, not drawn to scale, but it's close enough. Okay, guys, please stop talking. Thank you. I'm going to bound it by the axes in this region. These guys are going to come out as squares, just like the Tower of Hanoi. And I don't know where my model is. Okay, so there's my square. They're coming out at you like this. That's where I wish I had the 3D pen. But all I care about is the volume for the cross section, and I add them all up, Zach. That's all I do. So I'm going to try and draw it three-dimensionally, but I'll draw this side. This is the side of my square. How do you find the side of your square? S equals which value? X or Y? It's y. Now be careful. Read the question carefully. I'm doing it perpendicular to the x-axis. If I do it perpendicular to the y-axis, then it will be x. And I've seen students do that lots. They'll switch them, not read it carefully. Okay, so now here's what I'm going to try and do. I'm going to try and draw this. This is x, this is y, side, and this is z. And when I draw these are going to look like this. It's very easy. Okay, and if I were to join these corners here, yeah, but you guys have seen bike helmets, right? And they come kind of to a little point. That's what it would look like. But do I really care what it looks like? Don't I just really care what one of these cross sections looks like? That's all I care about. This is the side, and what's the thickness here? Yes, because it's perpendicular to the x-axis. Okay? So this one's easy. Well, I think it's easy. Okay, Eric, how do I find the volume for one of those slices? Right there. S squared times delta x. So the volume is equal to the integral of s squared dx. What's s? Nick? S is equal to y. So it's y squared dx. Okay? But I don't want y in there, do I? Alex, do I want y in there? I want x's. What was y equal to? Y equals 1 minus x squared over 4. That's the function it's following. So I'm going to substitute that right in there for y. So the volume is equal to, yeah, but it's a calculator problem. This one's not even that hard. X, it's just a power rule. Squared dx. Now, where are the x's going between? We already figured that out. You probably forgot. What are the x's? They're going to start over here. Oops. 0, and that ended at 2. Right. Guys, Sect. 0 to 2. Now, what's your assignment? Your assignment is to do AP problems. That's what these packets, why I ran them. That's why everybody should have gotten one. And your assignment is to do, starting in 2004, actually there's one in 2003, might as well add that in there, and it's one in 2011. Did I give you 2003? Oh, no, I didn't. Oh, yeah, that I did. Let's see if it's in here. number 1. Maybe we should do that right now. It's the green packet. Homework. That wasn't listed. I'm going to sign it now. So we could do it together now. And it's got everything in there that's tough. And then 2011, there wasn't one last year. There wasn't an area volume problem last year. Oh. Unless I missed it. So 2011 ended up being a blue packet. If you need more, they're all online. Go to the Form Bs. Now, there were no Form B exams last year. Form Bs are the ones they take overseas. Oh, yeah. You can do 2011. You can do 3B. B and C. What? Could be. You want me to bring up the answer key? Yep. So you guys, I'm going to pause my recording, and you guys are going to try 2003 number 1. It's got everything in it. That's 1987. I have all the multiple choices, or do I? Now, these were all